Assalamualaikum warahmatullahi wabarakatuh. Halo guys, welcome back to me, Farhan Setiawan from Mekanika Fluids 03 with my NPM 220668248110. Okay, in this video, I'm gonna explain you about my compilation yesterday about fluid mechanics. Let's go to the video. Okay, the overview that I'm gonna explain is based on nature and natural. Next is compressive flow. Next, elaborate day 5 and the mic. And lastly, engineering problem solve. Okay, first let's talk about the nature and natural. What's the difference about these two sentences? Okay, uh, first I'm gonna tell you about based on fluid mechanics. What is nature and natural? Is it nature is fluid dynamics refers to world and process that govern and the behavior of fluids. It encompasses the study of the flow of liquids and gas, including their properties, interactions, and transformations. It includes the study of various phenomena such as turbulence, vortices, and laminar flows, which are crucial in understanding the behavior in fluids' different contexts. Natural and fluid dynamics describe something that occur or exists in nature without being created uh, and by caused by humans. This includes natural processes such as the flow of water through a riverbed or the movement of air through the atmosphere. It also includes the study of how fluids interact with their environment and how they are influenced by natural force such as gravity and friction. These examples about nature and natural in fluid mechanics base. First is a GFD software is not natural because the fluids are being made by computer and that run by the simulations. Hence of the CFD software are artificial. Meanwhile, using natural fluid to run things like wind turbine or water turbine that benefits from real wind from the flow. A wind tunnel is also an examples of an artificial machines that provides wind. Usually, it was used to an airfoil on the natural part airplane when it was being used to fly in the air in real life. It will benefit from the wind that pass by. There are a few examples of things that are natural. Okay, next, it's all about a compressible flow. My intentions about understanding the compressible flow is I attempt to truly understand the definitions and principles of compressible flow, include the effects of compressibility on fluid dynamics, and apply this knowledge to analyze and solve real-world problems in aerodynamics and aerospace engineering. My initial thinking is to begin analyzing compressible flow. We first identify about properties of the fluid at the initial and final conditions. This involves determine whenever the fluid is a gas or liquid and establish its initial pressure, temperature, and velocity. Next, we categorize the flow as subsonics, transonics, supersonics, and hypersonics and identify whether the flow is one-dimensional, two-dimensional, or three-dimensional. It is also crucial to note if the flow occurs through pipes, nozzles, diffusers, or other geometries. Finally, we ensure that principles of mass, momentum, energy conservations are applied in the analysis. The comprehensive approach allows us to accurately model and predict the behavior of the compressible fluids in various engineering applications, such as high-speed aircraft, jet engines, and gas pipelines. Okay, the idealizations to begin analyzing compressible fluid flow. We first identify the properties of the fluid and the initial and final conditions, and involve determining whether fluid is a gas or liquid in is it initial pressure, temperature, and velocity. Then we categorize the flow as a subsonic, transonic, supersonic, and or hypersonic, and identify whatever the flow is one-dimensional, two-dimensional, or three-dimensional. And finally, we ensure that principle of mass, momentum, and energy conservation are applied in the analysis. To solve compressible flow, we utilize the fundamental equation, ensuring mass conservation through the continuity equations. Momentum conservation is governed by the Navier-Stokes equations from the compressible fluids, while the energy conservation is described by the energy equations. Additional equations like the ideal gas law, the speed of sound, and the Mach number are essential. By idealizing the compressible flow as a one-dimensional, isentropic, and frictionless process, we can analyze the flow behavior under various conditions, including change in pressure, temperature, and velocity, to gain a deeper understanding of the fundamental principles governing compressible flow. The comprehensive approach allows us to accurately model and predict the behavior of the compressible fluids in various engineering applications, such as high-speed aircraft, jet engines, and gas pipelines. It's the same as initial thinking before. Okay, the instruction is to comprehend compressible flow. Start by identify the fluid's properties and initial conditions, then categorize the flow and determine its dimensionally. Ensure the application of mass, momentum, and energy conservation principles and utilize fundamental equations to solve problems. To solve problems, establish initial condition and assumptions, use continuity, momentum, and energy equation to determine stream properties, and apply isentropic relation for isentropic process, ensuring the results align with conservation law and flow characteristic. Okay. For the third questions in the quiz, perhaps is elaborate the five and the mic. The I'm gonna tell about the five overview first. First is consist. That consist means ensuring oneself is consist before solving some problems. This means that before starting the problem solving process, an individual must ensure they are conscious and ready to think clearly and effectively. Secondly is intentions. That means having a clear and specific intention to solve problems. In this process, an individual must have a clear and specific intention to solve the problem so they can focus and think effectively. Okay. The third is means the initial thinkings. That means breaking down problem into specific and detailed parts. This process, an individual must break down the problem into smaller pieces, more specific parts, so they can think more effectively and detailed too. The fourth is idealizations. That means developing theoretical models and finding relevant formulas to solve problems. In this process, an individual must develop theoretical models that are relevant to the problems and find formulas that are relevant to solving the problems. Lastly is instructions. That means providing step-by-step solution to problems. In this process, an individual must provide step-by-step solution to the problems so others can follow and solve the problem effectively. Okay, next about the mic overview. That the definitions of the in this DMAIC part is to clearly define the problems, goals, and requirements. The steps involve identify the specific issue, determine the objective, and outlining the necessary conditions for a successful solution. Secondly is measure. That measure is to quantify the problems by gathering data and metrics. These steps involve collecting relevant information to understand the scope and impact of the problem visit, allowing for a more accurate assessment of the situations. Third is analyze. That means to identify the root cause of the problem. These steps to focusly on involve is examine the data and information gathered to determine underlying reasons for the problem rather than just addressing the its symptoms. Uh, Fourth is improve. improve, to develop and implement solutions to address the problems. These steps involve creating and implementing a plan to resolve the issue, often involving the development of new process, procedures, and technologies. Lastly is control to ensure that the problem stay fixed and does not occur. These steps involves monitoring and maintaining the solution to ensure that it remains effective and the problem does not return. The similarities of the Make and the 5 is one, both the Mac and the 5 aim to understand, analyze, and solve problems methodically. Secondly, each step of both frameworks builds on the previous ones, creating structured approach to problem solving. Third is the initial thinking in day 5 parallels the divine and measure pace in the mic, whereas to problem is understand and quantified. Lastly, the idealization in day 5 is similar to analyze pace in the mic, focusing on understanding the root cause and formulating theoretical method. Let's talk about differences and the mic includes a control base to ensure the long-term success, which is not explicitly detailed in the A5 but can be improved through proper solution implementation and monitoring. The A5 includes unconscious and intentions part which the mic don't have. This part, the A5 ensures to stay conscious and always remember God and be thankful of Him as be thankful of it as being the creator. Lastly, we're gonna talk about engineering problem solve. That this topic focus on transition from laminar flow to turbulent flow. My intention is optimize the design a mixing chamber to achieve turbulent flow for fluid A and fluid B using a computational fluid dynamic or CFD to enhance mixing efficiency. My initial thinking is to maintain laminar flow in the system. We should investigate the relationship between the pipe diameters and flow rate to keep the Reynolds number below the critical value. My idealization is in ideal scenario, the fluid will exhibit a perfectly smooth laminar flow with minimal frictions along the pipe walls, allowing the four pieces control and minimal energy loss. The laminar flow is characterized by smooth, linear fluid motions. In contrast, turbulent flow is characterized by chaotic, irregular, and fluid motion with a random fluctuations in velocity and pressure. The transition from laminar to turbulent flow depends on several factors, including fluid properties such as viscosity and density, flow conditions such as velocity, pipe diameter, and surface roughness. For non-dimensional parameter is a key concept in analyzing laminar to turbulent transitions is the Reynolds number or RE. That is a dimensionless parameter that characterizes the ratio of inertial force to viscous force in a flow. Formula of the RE is fluid density times velocity times pipe diameter divided by viscosity. Okay, the criteria for the transition is the specific RE value at which transition occurs depends on the geometry and conditions. However, some general benchmark are used is RE um, is typically laminar for uh, under 2000. For RE above 4000 is flow is typically turbulence, and between of the 2000s and 4000 is transition zone when laminar or turbulent flow might be occur. Okay, I think that's it for my video. Thank you. Bye bye.